This is Math 6, Lesson 3-3, Writing Algebraic Expressions. Sometimes you need to find a quantity, cost, or amount. You can use an algebraic expression to model the cost of a night out with your family if you wanted to. In order to write out an expression, you have to know what some simple word phrases mean in mathematics. Just like words in English can mean the same thing, like chilly, cool, cold, they basically mean not warm. In mathematics, we have words that can imply addition, subtraction, multiplication, or division. If you don't know what these important words mean, it will make it very difficult to write and interpret mathematical expressions. So here's a list of some important mathematical words and what they mean. Some words for addition. Obviously, there's the word add. Then there's more or more than. There's sum. In addition, plus, greater, and increase. Now, I'm sure there are other words, but these are the most common words used for addition, with the mathematical term being sum. My mathematical term for addition is the word sum right here. For subtraction, you have less, less than, difference, subtract, decrease. When you were little, I'm sure your teachers talked to you about take away. If I have 5 apples and I take away 3 apples, how many apples do I have? These are some of the words that we can use for subtraction. The mathematical term that's most often used for subtraction is the word difference. Multiplication can have lots and lots of words. Most frequently used are product, times, multiply. Sometimes we can say doubled, tripled, quadrupled, quintupled, etc. That's why that one has so many different uses. Once in a while, you'll see the word of, and the word of will sometimes imply multiplication. The mathematical term used most often for multiplication is the word product. For division, we have quotient, breaking into groups and or breaking into parts, divide or divided by. All of those imply division. The mathematical term used most often for this is quotient. So the 4 circled words are the words you're going to see used most often, but that doesn't necessarily mean they're the only words that we will use, which is why I gave you all the other words. It's important to understand how these words work. Let's take a look at some expressions and see if we can get them into an expression from a word form. If I have the expression, quote, 2 more than X, I'm going to talk with you for a moment about the phrase more than. More than implies that something else had to come first. If I say I have $7 more than you do, in order to figure out how much money I have, you have to know how much money you have. So you have to know how much money you have before I can figure out how much money I have. Okay? So the expression for 2 more than X, if you see the words more than, whatever comes after that phrase actually comes first. Now, obviously, with addition, this really doesn't matter, because addition is what we call commutative. The order in which we add things does not matter. However, subtraction matters, so if you can do it correctly with addition, you'll remember to do it correctly with subtraction. So the phrase 2 more than X means X comes first, and I have 2 more than that, so I'm going to add 2 to the X. The expression 8 less than R, this less than means that R came first. So I have to write my R first because I have 8 less than R. So R comes, and then I subtract 8 from that because I have 8 less than whatever R is. The order for subtraction and division is absolutely critical. Addition and multiplication, because you can change their order without changing their answers, it is not as important. Write an expression for the quotient of y and 12. When you see the word quotient, that should trigger in your mind, oh, that means division. But we're going to write an algebraic expression. So if I'm going to write an algebraic expression for the quotient of y and 12, with quotient you write it in exactly the order that you read it. But I'm going to write an algebraic expression rather than a mathematical expression. So I'm going to say y divided by 12. You're going to use the fraction bar as your division symbol because that's the algebraic way of showing division. We avoid showing it this way because this way is not algebraic. This is not the algebraic way to show it. When we get into solving equations a little later in this chapter, you'll understand that they're not going to show them to you very often that way. They may start that way, but eventually they're going to get rid of this. So the y divided by 12 using the fraction bar is your preferred way. Will I mark the y divided by 12 the other way wrong? No, but I will probably rewrite it the correct way. Okay. The preferred way is to write it algebraically. Okay, we can also take bigger phrases. Like an ad reads, buy 3 t-shirts of the same kind, take $5 off the total. If you let T represent the cost of 1 t-shirt, you can write an algebraic expression for this particular situation. Now notice we're keying here. The word does say algebraic right here. So I want to write this using algebra, which means I'm not going to use the little x for the multiplication symbol. I'm not going to use the little division symbol. I'm going to use the fraction bar. That's what algebraic means. So the first thing I'm going to realize is if T represents the cost of 1 t-shirt, and I have to buy 3 of them before I can take $5 off, I know that I need 3 t-shirts. So I'm going to multiply 3 times the cost of a t-shirt. And when you take a number and you put it right next to a variable, you do not need multiplication symbols. That just confuses people. A number next to a variable or a number next to a letter in algebra implies multiplication. So I have 3t, and if I'm going to take $5 off the total, that means if I buy my t-shirts at whatever price they happen to be, if I multiply that by 3, since I bought 3, I can subtract $5 from my total cost because I'm getting a deal here. So 3 t-shirts minus 5 off the total means 3t minus 5. Brandon is 28 years younger than his father. Write an expression using Brandon's age to describe his father's age. Right? So, if Brandon is 28 years younger than his father is obviously older than him, and that makes common sense to us because you can't be the son of somebody that you're actually older than. Right? So, if I let B, I have to have a variable here. So the first thing I'm going to do is describe a variable. Since we're using Brandon's age to describe his father's age, I'm going to let B equal Brandon's age, Brandon's age, excuse me. Okay. If B equals Brandon's age, and Brandon is 28 years younger than his father, and I want to find his father's age, if I take Brandon's age and I add 28 years to that, I should get his father's age. So that's the algebraic expression to describe Brandon's father's age. Now you'll see in this particular problem, we had two parts to it. We had to describe a variable because in the last problem they said let t equal the cost of one t-shirt. Here they said write an expression using Brandon's age to describe his dad's age. Well, in order to do that, I needed to tell you what my variable was, and I had to explain to you what I made it stand for. I called that defining the variable. I used the variable b, but I had to define it and tell you what b stood for. You can see the relationship between numbers when they're organized in a table as well, and you can use an algebraic expression to describe the relationship. Remember before when we were doing tables, we always were figuring out the next few terms by going, like if I wanted to find the 6th and the 7th and the 8th term, I would look and see the pattern here, which meant I always had to keep doing the numbers on and on and on. If I wanted to find the 100th term in this pattern, I would have to do 99 numbers before that. I don't want to have to do that. That is really, 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 really cumbersome. If I want to find out what the 100th term in the pattern is going to be, I don't want to have to do 99 of them to begin with. Anyway, this doesn't go in order. First term, 4th term, 5th term. Oh, goodness, that's rather hard. So if I'm trying to find a number pattern where I'm not saying find the next few numbers in the pattern and they go up consistently, I want to find a relationship between the top number and the bottom number. Now I'm looking to say, oh, what do I need to do between here and here? What is the relationship between my top number n and my bottom number? If I look at my top number and I go, what do I have to do to get from 1 to 3? Well, I could add 2, but that doesn't work for 4 because if I add 2 to 4, I only get 6. I could multiply by 3. So if I look at this and I go, 1 times 3 equals 3. Here, 4 times 3 equals 12. And on this last one, 5 times 3 equals 15. So I think I found the pattern here. I take the top number, which happens to be n, and I multiply it by 3, and I get to the bottom number. Okay, basically, this is called your term right here, and this is called the value of your term. So my first term has a value of 3, my 4th term has a value of 12, and my 5th term has a value of 15, which means my nth term, n here, we call that the nth term, is going to have a value of 3 times n. So my algebraic expression that describes the relationship of this data is 3n, which means if I wanted to find my 100th term, I'm not going to have to do 99 terms to do it. I can just look at that and say, oh, my 100th term, if I said find the 100th term, my 100th term will have a value of 3 times 100, which equals 300. And I didn't have to do 99 terms in front of that in order to find this 100th term. And this ends lesson 3-3.